good news and bad news. So the final renders are done. I've got a good slap comp. I think everything's looking great. However, with the power of hindsight, I've learned some things. So we're going to have to make some changes to this. Nothing major, but I did have a few hiccups with my renders, and we'll want to fix those before you guys decide to render your own things. So I'm going to jump into a few things that I changed to get rid of any sort of errors that might occur, and I'll tell you why we're changing them. First of all, we're going to dive into the set geo. Over here, I've just made a new set render so that nothing gets affected down the chain that's being pulled from out set geo. We just want to change the render of this. So what I've done is I'm going to go to this boolean here, and we can see that I just increased the resolution of the sphere. So it's just got more to work with, and then I've also done that with the polywire and just made that resolution higher there. Now when we render this, what I was getting is that light was being bounced off of here, and since I don't really have normals on points here, it had some issues since I'm also not subdividing. Since this is boolean and not modeled, it doesn't have edge loops to allow for subdividing. So we need this to be pretty dense so that when it's rendered we have a smooth mesh. Before it was too low res, so I was picking up edges along the bowl. So the lighting wasn't quite perfect. It could have been potentially passable, but I think this way it'll look a lot better. So next up is our geolight. What was happening was, and I'll show you if we dive into magic, right here I have this point wrangle, and I need to kill this point wrangle, because what's happening is this just disappears after frame 1081, and I figured that the timing would work out that it wouldn't look too jarring for it to just turn off, but it turns out that it is a bit too jarring. So what'll happen is you have this light source that just boop disappears, and it didn't look right. So what I've done is I've created a group here, and there was a resample here that I've gotten rid of, but this group then allows us to only edit this intersection when they're being merged here. So then this goes to the light geo. So we're going to dive over to the light geo, and over here I've done a couple things. So I'm going to kind of go back in the timeline, and I'll give you an idea of what's happening. So here is our intersection straight up, and we can see that none of these lines actually connect to each other. And I had mentioned earlier in the tutorial that you can do something about it, but I didn't think that we needed to. I thought that we could just use the points and call it a day, but we have some problems with that. And so what I'm going to do is I polypath it. And so then what that does is if you go here and put this directly after your intersection, it will turn all of those individual lines into one line. As long as it's connected, there's just one line. Then I resample it, and what we need to do is we need to resample at maximum segment length rather than maximum segments, and that makes sure that no matter the distance or length of this curve, it will all have the same spacing between these points. Because what we're going to do is we're going to polywire this, and we don't want too dense of geometry for the polywire, otherwise we could crash the box, and we don't want that. So then I'm still coloring it, still changing the P scale, but then what I'm doing is I'm creating a point wrangle here. And so this point wrangle, all it's doing is multing down. It's taking the P scale and it's multiplying by a scale, but we're only affecting the bottom wire. And we don't have a good means of procedurally making the bottom wire disappear because it's just an intersecting curve through geo that isn't exactly the same as the water. And because of that, what we're getting is lines that are left over, and we don't want any leftover lines. So what I've just done is instead of having it go from 100% there to not there, I'm taking the P scale of this curve and multing it down from 1 up here at 1067. And I know that the line down here stops around 1074, so I just make sure by 1075 it's 0. And then what we're doing is with the polywire, we're taking wire radius and just saying that the radius is P scale. So if I do this, we can see that we still have some of the geo left over here, but down here it's gone. Another thing that we do want to do though is we want to up the divisions, so it's more circular. And then also turn off prevent joint buckling. Otherwise we get these weird spikes. There's other ways to prevent it, but this is the best. We don't need our geo to be perfect since it's just a geolite, so these joints can buckle all day long if they want. So this will make it so that the light at the bottom will fade gradually into nothing rather than just turning off immediately. And it looks much better that way. And then the last thing. So this is going to be a little processor intensive, but I think it's the best way of solving this issue. I thought that we could get away with, so I'm going to go into the ice, and you're going to see some new things here. So I thought we could get away with just having this Boolean geo switch so that on frame 1000 it goes from our VDB to our Boolean geo and the leftover geo of the ice crystals. And it does work, except for on this flip you can see a little bit of a difference between the way that the light is refracting through the ice. And if you see any sort of blip at all, then it defeats the purpose of this. So we need to make it perfect. And I found that the best way to make this perfect is first, we needed to do a VDB from polygons of all of this. And we needed to make it so that the voxel size was very low, so that we maintained a lot of detail. The problem with turning it to a VDB is that it no longer has the attributes, and we needed the rest attributes in order to be able to put these noise point VOPs down here. But it's really easy to get the attributes back on it, where if you go to a convert VDB, there's transfer surface attributes. So if you turn this on, then anything that you put in this should be your surface prior to VDBing, and it'll just transfer any surface attributes that you have on here. So this did solve the issue. Since everything is VDB, there's no inner geo until things start moving away, which means that light is going to refract through this exactly how you would expect. But there was another issue, and that issue is, so this VDB, once it got to where the ice was shattering and flying up in the air, it would hit a frame where it would just go for infinity. It just could not solve. And so the way to solve that is, if we go up here, I'm going to unmanual this. And no ice should be flying right now, but we're going to go to a frame where it is. Alright, so we can see that all our geo is flying, and it looks cool. I don't see anything wrong with this. However, if we hit points, let's go farther up. Okay, so here we can see that there's a lot of pieces that if I undo this point, they're gone because they have a size of 0. However, all those points are still there. And so something was happening where all these points, even though you can't see them, they do exist. And when we were VDBing this, it would fail because of that. So what we need to do is get rid of anything that has basically an area of 0, which we've done before. The only problem is, instead of having one object that we have to deal with, we actually have to deal with thousands of objects. There's thousands of pieces here. And so then if we look at this here, this might look kind of complex, but it's really not. So I'm going to go into manual mode here. So first we need to start with a for each piece, or each connected piece. So if I were to do for each connected piece, it creates this connectivity, and then you have this. And so what I'm saying is each piece is going to be measured, and it's going to be measured by this element type points. It's going to look for area. And then all I'm doing is, after that, I'm saying if the area, I have this channel here, it doesn't really need to be there, it's 0. So if the area is 0, which all of these points up here that were showing up were 0, like this is all area of 0. And so this just says if the area is 0 on these points in this individual piece, delete it. Then I have this compile begin and compile end, and the compile block is just really good at creating multi-threaded for loops. All you really need to know is that when you create one, it makes things go faster. So if you just do create compile block, put one at the top, one at the bottom. There are some nodes that are not compatible with this, but I found that a lot are these days. And so if you put this at the top and bottom of a for each loop, then it just speeds things up. So you don't necessarily need this if you like to waste time, but if you do want to save time and you have many cores, then this is the way to go. So if you put these here, so again, we got to compile begin for each, that it's just for each connected piece. Then we are looking at element type points, measure area, and then here we're just if area equals 0, remove the point. And we're just doing that here. So now that that's done, then if we write this ICE VDB out, there's not going to be any errors. It still takes a while, so that is one drawback, but it's the best solution that I found. So writing a VDB out per frame of this ICE, it does take some time. However, you can technically do this simultaneously since there's no computation happening. Well, there's no simulation happening. And because of that, if you have a means of splitting this up, then you could say, well, chunk this into frames of 10, and then you could have some sort of multi-threaded file caching going on. This is for if you're at a studio. If it's just you at home, then just kick it off and sit back for a little while, because it does take a while, but again, we need this to look good and perfectly seamless in its transition, so this is the best means that I've found for that. So then if we write this ICE VDB out, then everything is good to go. There's no hiccups, and basically, let's just take a look at the renders, and you'll see what I mean.